A skateboarder of mass 45 kilograms is at the top of a ramp. It shows that the skateboarder and the ramp, right? All right. Calculate the change in gravitational potential energy of the skateboarder. Potential energy is mgh. Mass is 45 for the skateboarder. Teeny tiny. And change in height is 1.8. So potential energy, or the change in potential energy, more or less works out to be the same thing. And this answer is 810 joules. Pretty easy. Let's move on to the next part. It's asking us, state two main forms of energy that increase as she is decreasing. Well, for one thing, as she starts falling, her kinetic energy is gonna increase. Pretty cool. What else? I'm gonna guess her losses will increase as well, or friction will increase. So friction will increase heat loss in the form of heat. So I'll just say something like frictional heat loss. Frictional heat loss. A 75-watt filament lamp in an office is accidentally left switched on for 63 hours. Wow. When the office is closed, calculate the electrical energy that's supplied to the lamp. Electrical energy supplied is we know the power, the work done. All right, what is the work done or the energy? It is power times time, which is, what is the power? 75, right? 75 times time, which is 63. Convert that into minutes, then convert it into seconds. Comes out to 17.01 times 10 to the power 6 joules, or just megajoules. Moving on. The efficiency is 0.1. What is the amount of light? So that's a useful amount. Efficiency is energy energy out over energy in, and energy outputted is something we want to figure out. Efficiency is 0.12. Out again is unknown x, let's call it x. In is, we just calculated it, it's 17.01 mega. And I'm getting 2 times 10 to the power 6. Let's just call it 2 megajoules. Na aapki na meri. 2 megajoules. During 30-minute period, a mass of 4.2 times 10 to the power 7 of air enters the turbine with a speed of 15. So it's mass of air. Calculate the kinetic energy of this air. So I think they're using a wind turbine. Anyway, over here, the velocity and the mass is given. So we'll use kinetic energy formula, half mv squared. And, well, it's still half. Half is half. The mass is 4.2 times 10 to the power 7. And the velocity is 15. But I have to square it now. I'm getting 4.725, which is as good as 4.7 times 10 to the power 9 joules. So it says electrical energy, but it's a simple power question. Power is equal to work done over time, and this looks weird, but it's a W. And this y'all is equal to, well, I'll make work the subject. It's power times time. And then work is equal to The power is 8.4 times 10 to the power 5 times the time, which is 30 minutes. Gotta convert that into seconds. 1.5 times 10 to the power 9 joules. And now they want us to calculate the efficiency. That's kind of going to be simple. Efficiency is output over energy input. Well, the output came out to be 1.5 times 10 to the power 9, and input is 4.725, or 4.7 is fine as well. 10 to the power 9 again, this cancels out. And so in decimals, you can give it a percentage. So let's go with percentage. It's 31.7%. A rock from space is traveling at high speed towards the planet. Complete the equation for the kinetic energy of the object traveling with a speed of v and state what any other terms in the equation might represent. Well, that's kind of a silly question, isn't it? The kinetic energy is given by half mv squared, where v is the velocity. They've already defined it. And they're asking any other thing used in the equation, just define it. So we're using m, which is what? The mass of the asteroid. Mass of, what is it? Asteroid? A rock. Mass of rock. Shows a lamp from a car. Complete the boxes to describe the transfer of energy that takes place when the lamp is switched on. Well, what is the energy supplied to the lamp? It is in the form of electrical energy, and it is transformed into heat energy and light energy. It's kind of cool. You find the term efficiency, and you can just explain the equation. What is the equation? It is the boom and over the total energy that's inputted.